Good afternoon to everyone. Welcome to this live problem solving session for the course on traffic engineering. My name is Sethi Vinayaka. I am a PhD scholar in the civil engineering department at IIT Madras. Okay, so the objective of conducting these live sessions, these weekly live sessions, is to go through the concepts that are being taught every week, like in the lectures. So we will revisit them. If you have any doubts, you can get those clarified. And also, the aim is to help you, understand these concepts so that the weekly assignments can be solved. Right. So we'll be having assignments every week. Right. So we'll look at some of the concepts that are being taught and then some related problems in the same format in which you'll be facing them in the assignments, right? So the idea is that you will be able to get your doubts cleared and also solve the weekly assignments. Okay, so that's the overall goal of these sessions. So every week we'll be having these sessions, right, on Saturdays at 4 o'clock, right? So we will be covering the content of the lectures from that particular week, right? So we are starting with week 1 today. So let's start with an overview of what was taught in week 1 of traffic engineering. Okay, so we had 5 lectures in week 1. So the first lecture was an introduction to what traffic engineering is, right? As a subject, what is covered in traffic engineering, what is its objectives, and also we looked at the role of the transportation demand and land use. So in particular, so what is traffic engineering? So it is basically a branch of civil engineering where we deal with the safe and efficient movement of both people as well as goods using the roadways, right, in a multimodal system. So we are concerned with the movement of people and goods, right? So that's the overall goal, right? We want people and goods to be transported from one location to the other using the road system, right? So in traffic engineering, we'll be dealing with the road transportation, right? As you are already aware, so we have different types of transportation systems, right? So roadways, railways, air transport, and water transport. But in traffic engineering, we'll be mostly focusing on the road transportation. And also we'll be dealing with a multimodal system. So what is a multimodal system? So there will be different modes of transports that we will be working with, right? So even within the roadways, so we have private modes and public modes, and even within that we'll have sub classification, right? So there'll be cars, two-wheelers, trucks, and so on, right? So we'll be dealing with all these different modes of transportation running on the roadway system, right? So and how they'll be used to move people and goods in the system is what we'll be dealing with in traffic engineering. Okay, and in doing so, we have multiple objectives, right? So we classify them into two major categories: the primary and the secondary objective, right? So what's the primary objective? So the primary objective is the safety, right? So we want to move people and goods in a safe manner, right? So we do not want any accidents, right? So safety is the utmost priority when we are doing this traffic engineering, right? So that's why it's a primary objective, and there are other secondary objectives, right? Once so we ensure safety, but it's not enough that we just ensure safety. There are other aspects that we need to consider, right? So we want other desirable characteristics or objectives that we want to achieve, and these are called the secondary objectives, and we have multiple secondary objectives. Like we have the speed, right? So we want people to move faster from one location to the other. So we want goods to be delivered soon, right? So which is all dependent upon the speed of the movement, right? So speed is one of the secondary objectives. Then there is comfort, right? So how comfortable the trip is, right? So for example, if the road is undulated, so you'll have bumpy rides, right? So that's not a very comfortable trip. With respect to public transportation, the crowding level inside the vehicle, so that will affect the comfort level. Or air conditioned vehicles versus regular vehicles, so all these are related to the comfort level, right? So that is one of the secondary objective. Then we have convenience. So what is convenience? Convenience is basically how easy it is to make the trip, right? So if you want to move from A to B, so how difficult or easy is for you to take the car or take a bus to go to the location that you want, right? So how easy it is to make the trip, so that defines the convenience. That is one of the objectives. Then we have economic objectives. So economic objective is mostly in terms of the money involved, right? So for the users of the transportation system, right? So it is the cost involved, right? So if you are taking your personal vehicle, so the fuel cost is one of the points that you will be concerned with, right? So if you are taking the bus or a train, so the ticket cost will come into the picture. From the supply side, we'll have the cost of building the infrastructure, maintaining the roadways, so on. So all these come into the economic aspect. So we want to save money, right? So that we are economically sustainable in the long run. And finally, we have the environmental objective, right? So environmental impact is one of the most important goals, right? So we want to minimize the impact of the transportation system on the environment. So we know among the road transportation system, road transport is one of the leading contributors to the air pollution, right? So we want to minimize that. So air quality, noise pollution, so all these we want to minimize. So that's the environmental objective. So we want to have a balance between our primary objective and secondary objective. While ensuring safety, we also want these other objectives to be met as well, right? And finally, we looked at the interaction between the transportation demand, land use, and facilities, right? So what is this? So here we looked at, when we have so we have different locations, right? So in a city, we will have different locations A, B, and C. So there will be different land use in these different locations, and different activities will be taking place. For example, A could be a residential location, B could be some recreational location, C could be some commercial location, right? So because of these different activities taking place at different places, so people from one location will want to move to another location to perform some activity, right? So there is a so because of these different land uses that are separated by location, so there is a need for people to make to travel, right? So there is a transportation need, and because of this need for transport, so we provide facilities, right? So we build roadways, so connecting these, and also operate trains, buses, and so on, so that people can use that and reach these activities locations. So what happens? So when there is a transportation need, so we provide the facilities, right? So when we provide the facility, what happens? The land that is adjacent to the transportation facilities, so though the value of those locations will improve, right? So when the value of those location improve, so some activities will take place there. So because of that, see, new activity locations will come up, and when new activity locations come up, what will happen? There will be again need for transportation, right? Some people want to now go to this new location, so that will again make us to add new facilities, right? So you see, that's how this interaction between transportation demand, land use, and facilities takes place. So there is a cyclic nature in which these different components are interrelated. Okay, so that's all that we covered in lecture 1. So in lecture 2, we are introduced to this concept of mobility and accessibility, and also the different elements in a traffic engineering system. So what is mobility and accessibility? So basically, mobility is the ability of a system or a facility to facilitate or to allow through movement, right? So through movement, so when you want to get from place A to place B, how easy it is how efficient that particular facility is in accommodating the vehicles to move from the start to end, right? So the through movement, so the ease of making those through movement is what defines the mobility of that facility. And also we looked at accessibility. Accessibility is nothing but how easy it is to enter into the location or the facility, right? So it's about being able to use the facility, right? So mobility is how good the facility is in providing the through movement. Accessibility is how easy it is to access that facility, how easy it is to enter into that facility, right? So if it is if the road is if the location is well connected to the other locations, then it will be more accessible. And also this mobility and accessibility is defined for different facilities and different modes of transport as well, right? So there is a variation and between these facilities as well as modes for these mobility and accessibility functions. Then we looked at the different traffic engineering elements. So there is so this includes multiple elements including traffic characteristics, So the traffic characteristics are defined in terms of the volume, capacity, the speed, right? So all these define the characteristics of the traffic. And then there are performance evaluation criteria, right? So we define the performance of a system in terms of the level of service, right? So again, that level of service is affected by the speed and the congestion levels and so on, right? So using those, we evaluate how good or how bad a facility is performing. Then we have facility design aspects, right? So how we will design the, the roadways, the horizontal and vertical curves and so on. So geometric elements. And then there are traffic control and traffic operational aspects. Then transportation system management, and also finally the integration of all these facilities using intelligent transportation system, like for example automated fee collection, the cameras, the automated signal operations and so on. All these are coming under the ITS, or the intelligent transportation system technology. So all these are the different elements that we will be covering in the traffic engineering course. And there are four important components that make up a transportation system or a traffic system, which are the users, vehicles, roadways, and the control devices, right? So among these, the users and the vehicles, so these are out of the control of the traffic engineer, right? So we cannot control how a user will behave or how the vehicle is going to behave, right? So it's not in our control. Whereas the roadways and the control devices, so these are within the control of the traffic engineer, right? So these are the roadways designed, as well as the control devices are designed and operated by the traffic engineers. Therefore these two are the controllable components, whereas the first two are the uncontrollable components in the traffic engineering system. So in lecture 3, so in the further lectures, we were looking at each of these individual traffic system components. Lecture 3 was particularly dedicated to road users, right? So road users, so what did we see? What are the different characteristics of the road users that need to be taken into account, right, when you are designing a traffic system? So these include the visual characteristics, the perception and reaction times, the hearing characteristics, personality, and psychological factors, right? So why are we interested in this? Because the all these characteristics vary across the different users, right? So one person's visual acuity will not be the same as the other person, right? So one person's reaction time will not be the same as the other person, and there are a lot of factors that will affect this, right? So we will see a wide range of characteristics, variation in the characteristics across different users. And so how do we take these into account, right, to design our transportation system? So that's what we looked at in the third lecture. So fourth lecture, we were looking at the other components, so which is the vehicles, roadways, as well as the traffic control devices. So similar to road users, so the characteristics of the vehicles will also vary, right? Why? Because we have different varieties of vehicles, right? So the dimension of the vehicle, the weight of the vehicle, right? So all these vary, the acceleration, deceleration characteristics. So there is a wide range of values that these vehicles show, right? So how do we design then our system? So that's where we have this concept of a design vehicle, right? So because our designs cannot be adapted to each and every one of these vehicles, so we need to have one particular design vehicle, so designing for which will make sure that most of the vehicles that will be using that facility will be will be accommodated, right? So that's where the design vehicle component comes in. And then we were looking at, when we went into roadways, we were looking at the functional classification. So what is the functional classification? So these are based on the mobility and the accessibility levels that were introduced earlier, right? So the expressways, the arterial, subarterial, then the collector roads and the local roads. So these are the different functional classification in an urban environment, right? And these are varying by the mobility and the accessibility that they are offering. And finally, we are looking at the different types of traffic control devices, right? So we have the road markings, we have traffic signs, signals, delineators, right? So all are different devices that we use to control the flow of traffic in the roads, right? So these were introduced in the fourth lecture, and in the final lecture we were looking in particular about these traffic control devices, in particular the signs, delineators, and signals. So particularly in signs, so we looked at three major categories of signs, so which are regulatory, warning, and informatory. Right. So regulatory means it conveys a rule or a law that must be obeyed, right? So for example, the stop sign, the speed limit. So these are laws that people must obey, and violation of these will lead to legal actions. Whereas warning, on the other hand, warning signs will tell you about some hazard that the driver might encounter, ahead of the road, right? So that those are the warning signs. And finally, we have the informatory signs. These are just to provide information about the nearby locations or the facilities that are available in the surrounding areas, right? Then we looked at delineators. So delineators basically they help us communicate the alignment of the road or the presence of an obstacle, right? So on, right? So we have the roadway indicators, hazard markers, and object markers to help us communicate visually the presence of these different elements to the drivers. And finally we have signals. So signals help us control the flow of the traffic. Among that, we have three major types. So traffic control signals. These are the usual ones that we are familiar with, right? So intersections we have these, and then we have pedestrian signals. So this allows us to control the flow of pedestrians. So when they can cross an intersection or even a mid-block section. So the pedestrian signals help us that, and we have some special signals, special traffic signals like these flashing lights, so that informs the driver to be cautious, right? So and then uh, go cross that particular location. So these are the concepts that we were introduced to in the first week of traffic engineering, right? So what we will do now is go through some of the questions that are based on these concepts, right? So what I will do is I will display a question. So it will be in the same format as the assignments that you will be having, right? It will be mostly in the MCQ type, right? So we'll have the question and also the options. Then I'll create a poll in this call, right? So once you go through the question and when you are ready, you can answer in the poll, and then we'll look at what the right answer is and how do we get that. Okay, so that's how we will be continuing. Okay, to start with, the question one for week one is, which of the following statements is false with respect to mobility and accessibility? So option A is both mobility and accessibility of car is more than bus. Option B is mobility of an arterial road is more than expressways. Option C is accessibility depends on the proximity of the land to major roads. And option D is mobility depends on the effectiveness of the through facilities. Okay, you can take a moment to go through this and recall and then try to answer it. So while answering, I'll be creating a poll. So when you're ready, you can answer in the poll. Okay, I have launched the poll. You should be able to access it. So if you're not able to see the poll, let me know. Okay, any answers? Whenever you're ready, you can cast your answer in the poll and then we can see what the right answer is.
Sir, poll is not seen, sir.
Sorry?
Sir, it is not seen.
Not seen. So are you able to see this activities option in the call? So where you will access this chat and everything, there will be one activities option. activities menu.
Yes, sir.
Yeah, when you open that, within that there will be a polls section.
Okay, sir. Seen, sir. Seen.
Yeah. Okay, we have one vote so far. Any other answers? Okay, so there is no further answer. So we can look at the right option. So the right option is option B, is the mobility of an arterial road is more than expressways. So that is the incorrect statement. Okay. So this question is with respect to the mobility and the accessibility functions, right? So that we looked at in the second lecture, right? So what did we see? We saw that mobility and accessibility functions is defined for facilities as well as the different transport modes, right? So here we are looking at both of them. So the first option is talking about the different modes, right? So we are talking about car and bus and their mobility and accessibility. So it says that accessibility and mobility is higher for cars compared to bus. So which is correct. Why? Because so cars, you know, they provide you door to door, access, which means you can enter, exit from your house, get into your car, travel, get to the destination, right, the door of the destination, right? So they provide door to door access, which means they have a higher accessibility. Whereas to catch a bus, you need to leave your house, go to the nearest, stay stop, right? So you have to walk to it, or take some other form of transport, and then catch the bus, go to the destination again, get down at the stop, and then walk or take another mode to reach your final location, right? So in that case, accessibility is higher for a car. So mobility is also higher because cars, they can travel faster, they have higher maneuverability, so their through movement is also higher if you compare it with respect to bus. So in terms of both mobility and accessibility, car provides a higher value with respect to a bus. So first statement is correct. Whereas the second statement is with respect to the facilities, right? So the mobility of an arterial road is more than an expressway. So this is not correct because, see, when you look at the urban area, so the classification of the roadways is, so we have the expressways, right? So then we have arterials and subarterials. Then we have, collector roads, and then we'll also have the local streets, right? So let's say how the mobility varies and how the accessibility varies, right? So if you look at it, so the highest level, the expressway, they provide the highest mobility among all these different facilities, and the local road provide the least facility. So the direction of this is like this, right? So the mobility increases as you move up through these facilities, whereas the opposite is true in the case of accessibility. Accessibility is how easy it is to gain entry into this particular facility, right? So it is easier to enter into a local road, whereas it is very difficult because expressways are, access control, right? So you cannot get into an expressway at any location that you are interested in, right? So they have very high restrictions of entering into them because they provide a high throughput in terms of mobility. So the accessibility will be varying like this, right? So local streets have the highest accessibility, whereas expressways have the least accessibility. So here we are talking about the mobility, but if you look at it, expressways come up or come higher than the arterials, which means expressways have a higher mobility than arterials. So the second statement is the incorrect one. The third one says accessibility depends on the proximity of the land to major roads. This is correct, right? So when when the facility is closer to the land use, so which means it is easier to gain access to it, right? So the proximity is one of the factors which will affect the accessibility. And fourth says the mobility depends on the effectiveness of the through facilities. This is also correct, sir. This is by definition how we define the accessibility and the mobility, right? So therefore, C and D are also correct. So B is the only incorrect statement here. So which is the correct answer for this question. Okay, question number 2 is which of the following statements are false? So option A is economy of a nation depends on efficient movement of goods. Option B is minimizing the impact of transportation systems on the environment is not the objective of traffic engineering. C is providing safety and efficiency is a complex job in multimodal systems. And D is transportation demand is not a derived demand. Okay, so this is a another type of question which is multiple select. So where more than one option may be correct. Okay. So one or more than one can be correct. We have on board for options B and D. Any other answers? Okay. So the right answer is both options B and D. Okay. So here the first option is economy of a nation depends on efficient movement of goods. So this statement is correct, right? So the efficient movement of goods means efficient in terms of both time as well as money, right? So we want faster movement as well as to transport this using low cost, right? Low cost in terms of fuel, in terms of the the maintenance of the facilities or the maintenance of the vehicle. So all these come under the efficient movement, right? So we want to do it at low cost and also faster, right? So you want to save on time as well. So this will affect the economy of the nation. So A is a right option. So B says minimizing the impact of transportation systems on the environment is not the objective of traffic engineering. This is incorrect. So we saw that one of the secondary objective is the environmental compatibility, right? So we want to minimize the impact of the transportation systems, right? So the different impacts like air quality or the noise pollution and so on. So all these effects we want to minimize it. So that is one of the objectives, right? So it says it is not, therefore B is incorrect. C says providing safety and efficiency is a complex job in a multimodal system. This is correct. So again, because we are dealing with a multimodal system, we have a wide variety of vehicles and vehicular characteristics that we need to take into account, right? So because of that, so all these design characteristics or design of the system so will be much difficult, right? So rather than designing for one uniform set of vehicles, right? So therefore, that's why it's more complex in terms of ensuring the safety as well as the efficiency. So C is a correct statement. And D says that transportation demand is not a derived demand, which is incorrect. So what is a derived demand? Which means that the need or the demand for traveling from one location to another is not existing by itself, right? So people want to move from A to B because they want to do something at the location B, right? So they are at location A, they want to go to location B because they want to do or perform some activity there. If that need was not there, the need to perform that activity at location B, then the need to travel to location B will not be there, right? Because of the spatial separation of the activities is what is creating the demand for the transportation, right? So therefore, this demand for transportation is derived out of the spatial separation of these land uses and different activities, right? So that's why transportation demand is a derived demand. So D says opposite. So therefore, D is a false statement. So the right answer is options B and D. Okay, question number 3 is match the different objectives of traffic engineering given in column X with the corresponding description given in column Y. So we'll have four predefined options. Okay, so column X has the different objectives: environment, economy, convenience, and safety. Column Y has the descriptions as primary objective: ease of making trips, aesthetically pleasing facilities, and the best return against investment. We have one more for option B. Any other answers? All right. So the right option is option B. Okay, but we look at how the match is done. So the first one in column X is environment. So environment is one of the secondary objective, right? So what is that? So we looked at environment means we want to reduce the impact of the transportation system. So which is to reduce the pollution, air pollution, noise pollution, etc. But it is not just that. So we also want to design this aesthetically pleasing facilities. So what does that mean? So the facilities that we design should merge with the existing landscape, right? So we want to preserve the existing landscape, right? So do not want to disturb it. So we will design the facilities in such a way that they merge with the existing ones so that they are aesthetically pleasing, right? So that's also one of the objectives when we talk about the environmental impact. So one is matched with C. Two is economy. So in terms of economy, so we want best return against the investment, right? So that means the government is spending huge sums of money, right, in building the transportation systems, right? So which means the government is investing money. So which means the return on the investment, right? So the revenues that are collected should in the long term should be higher than the cost of these facilities, right? So only then financially these systems will be sustainable, right? So the profits should be there instead of the losses, right? So only then these facilities can be maintained and run for the long term. So that's the economic objective that we are concerned with. Third is convenience. So convenience is, as you can see, it is the ease of making trips, right? So how easy or difficult it is to make the trip, so that affects the convenience aspect of the objective. right? So we want easily trips to be made easily, right? So people want convenient trips. And fourth, safety. As we already saw, safety is the primary objective of traffic engineering, right? So we want to ensure, that accidents are not happening and people as well as goods travel safely from one location to the other, right? So therefore, that is the right mapping which is given in option B, right? So therefore, B is the right answer. Okay, question number 4. Yes, which of the following statements are true regarding traffic engineering elements? So option A is quality and performance of a facility is termed as level of service. Option B is facility design of transportation facilities refers to the structural and functional design of the facilities. Option C is curb management, one-way traffic systems, etc. are examples of intelligent transportation systems. Option D is general environment such as weather, lighting, etc. are part of the traffic engineering components. Okay, so we have one more for option A and B. Any other answers? Okay, so the right answer is options A and D. Okay, so here we are talking about correct statements. Okay, which statements are correct? So option A says quality and performance of a facility is termed as the level of service. So this is correct, right? So the level of service is one of the the performance evaluation criteria, right? So whether the facility is its level of service is higher or at least equal to the design level of service, right? So each facility is designed for a different level of service. So this level of service is defined in terms of other characteristics of the traffic like the speed or the congestion levels, right? So to evaluate the quality and its performance, we look at it in terms of the level of service of the facility, right? So therefore A is correct. So B says that facility design of transportation facilities refers to the structural and functional design. So we are looking at two types of design, the structural design and the functional design. Right. So when we talk about the facility design, so in traffic engineering, we are only concerned with the functional design part of it, right? And some geometric aspects, but not the structural aspect. Right. So structural aspect is taken care of by the structural engineering part. Right. So in traffic engineering, we are concerned with the functional design of the facilities. Therefore, here both are given. Therefore, this statement as whole is incorrect. C says curb management, one-way traffic systems, etc. are examples of intelligent transportation systems. This is also incorrect because these strategies come under a concept called traffic management system. right? So where we try to make use of the existing facilities. So without building any new infrastructure, how do we make use of the existing facility or the capacities of the existing facilities in an efficient manner, for the existing traffic, right? So this curb management, one-way traffic systems will all come under that traffic system management component, right? So ITS is different, right? That deals with the use of the advanced technologies, and it has a different set of strategies and technologies and devices that we will be using, right? So the solutions in ITS are different from this what is given here. So C is incorrect. So D is correct. So as part of the traffic engineering component, we take care of all these different the environmental aspect as well, like the weather, lighting. So these will define, for example, the markings that we'll use, the position of the the signs and so on. So this will affect the components or the elements of the traffic engineering design, right? So these are also included in the traffic engineering as well, right? So therefore the correct statements are A and B. Question number 5. We have to give a match the items in column X with the items in column Y. So column X has traffic characteristics, control devices, transportation systems management, and performance evaluation. Column Y has operational characteristics of the facility, optimizing the system capacity and operations, controllable components of the traffic stream, and measuring and quantifying several aspects of the traffic, such as traffic volume, travel time, etc. And these are the matchings that are given. Okay, so here one vote for option B. Any other answers? Okay, so the right option is option A. So how do we get that? So column X, the first one is traffic characteristics, right? So we already saw what this traffic characteristic or what components define this traffic characteristic. So this that is the traffic volume, the travel time, the speed. So all are characteristics of the traffic, right? So we define the traffic in a particular location based on these different characteristics, right? So the congestion, all these are defined in terms of these different characteristics of the traffic, right? So that's how the traffic is defined. So one is matched with B. Two is control devices. So control devices is nothing but uh, so as I said, out of the four components, the users, the vehicles, roadway, and the control devices, the roadway and the control devices, these are the controllable components of the traffic system, right? So users and the vehicles are not controllable with respect to the traffic engineering, right? So control devices are the controllable component of the traffic system. So 2 is matched with C. And 3, transportation systems management. So as we saw in the previous question, the curb management, one-way street. So these are some of the strategies or measures that are coming under the transportation system management, where the goal is to optimize the system capacity. So making use of the existing system capacity without building new infrastructure, we are trying to optimize the use of the existing system capacity, right? So that is the transportation systems management. And finally, performance evaluation. So to evaluate, as we saw in one of the earlier questions, so performance evaluation, how do we do in terms of the LOS, right? So with operating characteristics of the facilities. So the LOS is defined in terms of these operating characteristics, and based on that, we evaluate how good or bad is the performance of a given facility, right? So the performance evaluation is based on the operational characteristics. So 4 is matched with A, right? So that mapping is given in option A. Okay, therefore A is the right answer. Okay, moving on to question number 6 is which of the following statements are true? So A, green road marking is used to provide priority to cyclists and pedestrians. B is warning road signs are provided at approaches to intersections. And C, usually continuous road markings are provided in case of a warning situation. Okay, there is one vote for options B and C. Any other answers? Okay, so the correct statements are option A and option B. Okay, so first is green road marking is used to provide priority to cyclists and pedestrians. This is correct. So at intersections, so we use the green colored road marking. So that is for pedestrians and cyclists, right? So for the non-motorized transport, right? So that's where we use green, right? So we use different colors of road marking, for different purposes. Generally, we use white regularly, but sometimes we use yellow, right? Markings to, whenever there is no overtaking or in parking locations, and green is used for cyclists and pedestrians. So that is correct. So B is warning signs. Warning road signs are provided at approaches to intersections. So that is also correct, right? So we looked at the three categories of signs, right? So the regulatory, warning, and informatory. So warning signs, so like the yield sign. So these are provided at intersections, right? So the stop signs and the yield signs. So these will be present at intersections, right? So for example, when there is a yield sign, what does it mean? It means the vehicles have to slow down, right, and then look at whether it is safe to cross the intersection, and then make the maneuver, right? So those kinds of signs are placed at intersections, and these are warning. So warning means it is to caution the drivers, right? So then there is no regulation or a particular action. So these are just to warn them of the danger that is lying ahead. So the warning signs are present at the intersections. Whereas C says usually continuous road markings are provided in case of a warning situation. So this is incorrect. So where do we use continuous road markings? So if there is a continuous road marking, what does it mean? It is not permitted to cross that particular line, right? So when we see horizontal continuous lines on the road, which means that the vehicle should not cross that continuous line, right? So when it is a broken line, vehicle can cross it. If it is a continuous line, the vehicles cannot cross that continuous line. So this is not a warning situation, right? So this is a regulatory situation, right? So which means it's a rule that a vehicle should follow, right? So it's not warning but regulatory. Therefore, C is incorrect. So out of the three, only options A and B are the right options. Okay. So question number 7 is accept or reject the given statement. The statement is a person with a visual acuity of 6 by 6 is said to have a poorer vision than a person with a visual acuity of 6 by 8. It's like a true or false question. Any answers? Based on your understanding, whatever you think is correct, just mark that. We'll see if it's right or not. Okay. Okay. So we have one vote for A. Any other answers? All right. So the right option is option B, that we reject the statement because it is not correct, right? So visual acuity is one of the characteristics of the road users that is important for us to consider, right? Why? Because this affects, for example, the placement of the markers or the signboards, right? So the visual acuity of the person is something that needs to be taken into account, because what is visual acuity? It is the ability of the person to be able to see the small details clearly, right? So the clarity in the vision is important. So when we are designing the placement of the signs, for example, right? So therefore, we need to take this into account. So when we are looking at visual acuity, we will always be seeing like this pairs of numbers, right? So 6 by 6, 6 by 8, and so on. So how, what is that? What does that mean? So 6 by, so the two numbers, right? So let us say A and B, right? So what is this denominator? So the B represents the, the distance from at which a normal person can see an object, can see a given object, okay? Right? So a normal person can see this object from a distance of say b meters. So a is the same thing for the test person. So for the person who is being tested, so the distance from which this person can see that object, right? So that is the a slash b. Okay. So 6 by 6 means a normal person can see the object from a farthest distance of 6 meters, right? So and also this test person is also able to see the object from a distance of 6 meters, which means his visual acuity is same as that of a normal person, right? So this is a normal vision, 6 out of 6. So 6 by 8 means what? So a normal person is able to see from 8 meters, right? So normal from 8 meters, whereas the test person, right, can see only from 6 meters, which means that person being tested needs to move closer to the object in order to be able to see it clearly, right? Whereas if he is from 8-meter distance, he will not be able to see it clearly, but a normal person can see the object from an 8-meter distance, right? So which means 6 by 8 is poorer, right? So compared to a normal person, this person being tested is having a poorer eyesight, right? So that's what 6 by 8 means, right? So 6 by 8 is poorer vision than 6 by 6, right? So you just have to remember the second number is for a normal person, right? So that is the reference, okay? So the first number, the numerator, that is the person being tested, right? So with respect to the normal person, how is the eyesight for the person being tested? So 6 by 8 is poorer than 6 by 6, okay? Therefore, but the given statement says the opposite. It says 6 by 6 is poorer than 6 by 8, right? So therefore, we are rejecting the statement. It is incorrect, okay? Any doubts? Okay. So moving on to question number 8 is again accept or reject. So the main goal of traffic engineering is the safe and efficient movement of people from one place to another. So we have to accept or reject this statement. Okay, so we have one vote for B, reject. Any other answers? All right. So the right option is option A, that we accept the statement. It is correct. Right? So do not confuse this with the objectives, right? So the goal, when we talk about the overall goal of traffic engineering, right? So when we looked at the introduction, we saw what is the main goal or the overall goal of traffic engineering, which is to move people and goods, right? So here we are looking at the movement of people. It is also one of the, so goods is not here, but that doesn't mean it we are not considering it. So one of the main goal is to move people from one place to another, in a safe and efficient manner, right? So these are the objectives, right? So safety is the primary objective. So efficient has all those different objectives like the speed, cost, and so on, right? So these define the efficiency of the movement, whereas safety is the primary objective, right? But it is to move people as well as goods from one location to the other. So in this manner, right? So that's the overall goal, right? So this is correct. Therefore, we accept the given statement. So if it said it is the safe and efficient movement of only people, then in that case it is wrong, right? Or if it says the movement of vehicles, then it is wrong. But here the goods are ignored, but that doesn't mean it is not there. So this statement is not contradicting or saying anything false. So therefore we accept this statement. Okay, question number 9 is the reaction time of drivers will be less in surprise situations compared to alert situations. Okay, again we have to either accept or reject this. Okay, so we have one vote for B, reject. Any other answers? Okay, so the right option is option B, reject, right? So this given statement is not correct, right? So here we are looking at the reaction time. So this is also one of the characteristics of the road users that we need to take into consideration. So we are looking at two scenarios. One is the surprise situation, the other is the alert situation, right? So in which, so the reaction time in surprise situation and reaction time in alert situation, right? So alert situation means you are already aware of some of something of your environment, right? So what's going to happen, right? Surprise situation means so you are thinking that the normal conditions will keep on happening, right? So but suddenly you are faced with some hazard or some danger, right? So that is the surprise situation. So in these two situations, when will we react faster, right? So when we are already alert, so when we are expecting something out of the ordinary or out of the normal to happen, so in that case we will be able to react quicker, right? So compared to a surprise situation where we are more relaxed, right, and thinking that everything will be continuing in this normal fashion. So in that case, if something suddenly happens, so we will take longer time to process that and then react to it, right? So therefore in surprise situations we'll be taking a longer time, right, than in alert situation. Means for example, a simple case would be traffic signals, right? So for example, when you are waiting in the red, right, so and the timer goes down, so you know that it's going to turn into green, so you don't need too much time. So when the signal changes, to react and then accelerate and move, right? So that's why the reaction times in during intersection signal designs so will be lower than in other scenarios, right? For example, we consider 1 second as reaction time in signal design, right? So that is much lower than the signal reaction time, for example, when we are calculating the stopping side distances, right? So when we are in an alert situation, so we'll be expecting things to change, and therefore we'll be ready to react, right, to it. Therefore, this given statement is not correct. It says the opposite. It says RS is less than RA, which is not correct, right? So therefore, we are rejecting the given statement. Okay, question number 10 is yellow pigment is added to the green lights to overcome the difficulty for colorblind drivers on roads. So whether we accept or reject this statement. Okay, we have one vote for B. Any other answers? Okay, so the right answer, the option B, that we reject the statement because so even though to help the colorblind drivers, we do add some other color pigment to the traffic lights. Yellow is not added to green light, right? So yellow pigment is added to the red light, whereas the blue pigment is added to the green light, right? So therefore they'll be able to distinguish the red and green, even though they cannot distinguish red and green directly. This addition of yellow pigment and blue pigment to these lights will help them distinguish between the two, right? So the given statement is opposite. It says yellow is added to green, which is incorrect, right? So yellow is for red and blue is for green, right? So therefore we reject the given statement. Okay, question number 11 is the knowledge of visual acuity and field of vision is essential for a traffic engineer dealing with the design and placement of road signs. Okay, A is accept, B is reject. Okay, there is one vote for A. Any other answers? Okay, so the right option is option A, that we accept the statement. Right, so as I already mentioned, right, so when we are looking at the visual acuity question, so why is it important to know or to learn about visual acuity and the field of vision is because it helps us in designing the components, right? So for example, in the placement of road sign, right? So the vertical placement as well as the horizontal placement, the lateral placement of the signs is based on this visual acuity and the field of vision, right? So the visual acuity will tell us, from how far away a person with a normal eyesight can see and read the sign clearly, right? So that is important, right? So for example, so based on that, based on that as well as the stopping sight distance, the position of the road sign on the road will be decided, and based on the field of vision, the horizontal as well as the lateral placement. So we know at this location we have to place the sign, right? So if therefore the vehicles can safely stop in case of some hazard, but at what position along the road that we keep it. So that is based on the field of vision, right? So we know that within the field of clear vision, right, is where within the 3 to 10 degrees, right? So we have to place this signs so that they can able to read it, right? So therefore the field of vision comes in place for the vertical as well as the lateral position, right? So visual acuity will come into action when we are deciding on the position of the sign, right? So both of these are important, right? So therefore the given statement is correct, that it is essential for designing the road signs. Okay, question number 12 is the relationship between the land use and transportation is cyclic. So we have one vote for A. Any other answers? Right. So right option is option A, that we accept this. Right. So you might remember this figure from the lecture. So we have the land use, and then we have the demand, which is transport demand, and then we have the facilities. Right. So all these three are interlinked. So in what way? Land use will affect the transportation demand. Right. So as I said earlier, the separation of these different land use and activities is what creates the transport demand, right? And with the transport demand creates a need for people to travel, and which forces or creates the need to have these transportation facilities. And by having these different transportation facilities, right, affects the value of the land around these facilities and changes the land use, right? And because the land use changes, the demand is affected, and so on. And this pattern keeps on repeating, right? So this is a cyclic relationship that exists between the land use, demand, and the transportation facilities, right? So this statement is correct, right? So therefore we accept it. Okay, question 13 is the average spacing between the vehicles is 7 meters under the jam conditions. Estimate the jam density in vehicles per kilometer. So the options are 0.007, 7, 143, and 21. Okay, we have one vote for option C. Any other answers? Okay, so the right answer is option C. It is 143. But how do we get it? So what are we given with? We are given with the average spacing, right? So S average is 7 meters, and this is in the jam condition. Okay, so we want to calculate the density, which is represented by J, and because this is jam condition, this is, we can call this as Kj, which is usually the notation that we use to represent jam density. Right, so how do we calculate it? So the density is in terms of number of vehicles per kilometer, right? So what is the spacing? So spacing is between the gap between two vehicles, right? So this is vehicle 1, vehicle 2, vehicle 3. So this is on an average, it is 7 meters, right? So if so we just need to find out in 1 kilometer of road, right, how many 7 meters can be fit, because if there are two 7 meters, which means that there will be three vehicles on that road, right? Because for every pair of vehicles, the gap between them is 7 meters. So to know how many vehicles are there in 1 kilometer, we need to find out how many 7 meters are there, right? So in 1 kilometer, which is 1000 meters, how many 7 meters are there? So it will be 142.8, right? So approximately this is 143 number of vehicles in 1 kilometer, right? So that's how we find the jam density. Okay, so the right option is option C. Okay, question number 14 with respect to road signs, right? So we have to choose the correct options. So we have four signs. So they are marked as P, Q, R, and S. Okay. So option A is P is a warning sign, Q is informatory, R is regulatory, and S is also regulatory. So like that, we have four matchings given, right? So we have to pick the correct matching. Okay, so we have one vote for option C. Okay, any other answers? Okay, so the right option is option C. Okay, P is regulatory, right? Because stop sign is a regulatory sign, right? So we had regulatory, warning, and informatory as the three categories, right? So the regulatory means it implies a law, right? And therefore a violation of it, it's a legal offense, right? So warning, it means it is telling us about some hazardous situation ahead, right? So and to caution the drivers. And informatory is to just give information about the facilities that are available in that particular surrounding, right? So P is a stop sign, which is a regulatory sign. Q is parking. So parking comes under informatory sign, right? So how do you distinguish? So regulatory signs are easier to distinguish because they have a particular shape, right? So they are usually circular in shape, right? So but except with this stop sign, which is an exception, this will be in octagonal shape, right? So generally they will be in circular shape. So P here is an informatory sign, right? So it is just to let users know that this area here is available for parking. And R is a warning sign, right? It warns drivers of a left turn ahead, right? So the way drivers will be more cautious that the road is going to turn, right? So ahead. Right? So therefore, R is a warning sign, and S is a informatory sign again because it tells us about the presence of a hospital or some medical center, right, in the vicinity, right? So therefore S is a informatory sign, right? So P is regulatory, Q is informatory, R is warning, and S is informatory. So C is the right matching. Okay, question number 15 is which of the following figures are correct regarding the speed flow density relationships? Okay, so we have three figures. So this is figure 1, this is figure 2, and this is figure 3. Okay, so the different figures represent the different relationships. So the options are figures 1, 2, and 3 are correct. Option B is only 1 and 2 are correct. C is only 1 and 3 are correct. Excuse me, and D is none of these. Okay, so we have one vote for A. Any other answers? Okay, so the right answer is option B, that only figures 1 and 2 are correct. Okay, so here we are talking about the speed, flow, and density relationship. Right, so these are the three fundamental parameters of traffic flow. Right, so speed generally represented using V, flow using Q, and density using the variable K. Okay, so what is the relationship between these three parameters? So flow is equal to the product of density and speed, right? So Q is equal to kV. So this is the fundamental relationship that we have, right? So if you look at it, the first figure is the relationship between speed and density, right? So we are looking at two variables at a time. How speed varies with density. So at low density, which means right in free flow conditions, right? So there is not much vehicles on the road. So at that time you will be experiencing the higher speed of the traffic flow, right? So at low density, your speed will be high, and here at higher densities, your speed will keep on reducing, right? And when you reach the jam conditions, right? So the no, none of the vehicles will be moving and your speed will drop to zero, right? Therefore, this relationship between speed and density is correct. So second, we are looking at the relationship between flow and density, right? So at low densities, you will have low flows, right? So when there is no vehicle on the road, so you don't have flow also. So what is flow? Flow is nothing but the number of vehicles that are crossing a particular point or location per unit time, right? So if the density is low, which means fewer vehicles will be crossing that particular location. So on the other hand, when the density is near jam conditions, then the flow will also reduce at the time because the speeds will drop, right? So from the previous relation, we know speed is low, right? So speed is almost zero at jam condition. So CQ is dependent on both density and velocity. So density is high at jam condition, but velocity is low. So these two, when they are multiplied, so Q will also go down, right? So therefore, at high density as well as at low density, you will have very low flows, and at some critical density, you will have the maximum flow happening, right? So therefore, the second relationship is also correct. So the third relationship is between the speed and the flow, right? So Q and V. So this particular relationship is incorrect. Why? Because what is the true relationship between speed and flow? It should be like this, right? So on the x-axis we have the flow, y-axis we have the speed. So what does that mean? So at a low flow, so there are two possible values of speed. So this is high speed, low speed. So let us say this is the free flow speed. So what is free flow speed? So when there is near zero flow, right? So almost no traffic is there. That means a vehicle is not influenced by its surrounding vehicles. At that time, you will be realizing the free flow speed, right? So vehicles will be able to travel at a higher speed, right? So this is possible when the flow is near zero, right? So your speed will be higher. Or there is another case, the when can flow be zero? So it is possible when the when we are experiencing jam density. So in the jam density case, the speed will be zero, right? So from the first relation we know that, right? So at this point, right, so density is low, flow is also low, but at low density speed is high. So that is corresponding to this point here. So whereas this square point, flow is again zero, but density is high, and that will be giving you low speed. That corresponds to this particular point, right? So two speeds are possible for a given value of flow, right? So that relationship is given by this kind of this 3 prime, figure 3 prime, okay? So this is the true relationship between the speed and flow, okay? So two speed values are possible for every flow value, right? So one is in the free flow condition, so that is the higher speed range. Another is at the congested condition, which is the lower speed range, right? So therefore, this is the right one. So only figures 1 and 2 are correct. Figure 3 is incorrect. Okay, so therefore right answer is option B. Okay, any questions? Any doubts here? Okay, so there are no doubts. We move on to question number 16. So the approach of an intersection is termed as oversaturated when the V by C ratio is dash. So the options are greater than or equal to 1, less than 1, less than 0.5, and none of the above. Okay, so there is one vote for option A. Any other answers? All right. So the right answer is option A, that when V by C is greater than or equal to 1, that's when we call it oversaturated, right? So what is V by C ratio? So V is the, here V is not speed, here V is the volume of that of the facility or the roadway, and C is the capacity, right? So we are looking at the capacity, volume to the capacity ratio, right? So if it is less than 1, which means that volume is less than capacity, right? So the flow taking place in that particular road is less than the capacity of the road. In that case, we call it undersaturated, right? So when volume is equal to capacity, this is at capacity, right? So we are using it to its capacity, and when it is greater than capacity, so it is oversaturated. Right? So that means V by C is greater than 1, right? So here we have included both at capacity as well as above the capacity. So in that case, it is oversaturated. So which means your delays will be much higher. Okay, question number 70, accept or reject. The level of service analysis is independent of the road facility and the travel mode. Okay, we have to say whether we accept or reject this statement. There is one vote for option B, reject. Okay, any other answers? Okay, so right option is option B, that we reject the statement because the level of service. So we saw what where do we use the level of service when we are looking at the performance evaluation, right? So how well is a facility performing? So that's when we go for the level of service analysis. So here this it says the this analysis that we perform is independent of the type of the facility and the type of the mode that we are considering, right? So which is not correct because the level of service analysis will change depending on the type of facility that we are working with. Why? Because we design different facilities for different levels of service, right? So we have levels of service from A to F, right? So A is the highest level of service, right, and F is the lowest level of service, right? So we do not, design all the facilities for the same level of service, right? So as we have the different functional classifications, for example, the lowest level in the functional classification is your local street. So you do not design your local street for level of service B or level of service C, right? So that is wasting the resources, right? So it does not need that high level of service because the volumes that it is going to experience are low, right? So therefore, whereas if you look at the arterials or the expressways, there your level of service will be higher, right? So we design it for a higher level of service because it's going to cater to a higher, volume levels, right? So therefore, it is not same across all the facilities and also for all the travel modes, right? So different modes will be catered to different levels of services, right? So it is not independent of the facility or the travel mode, right? So it is dependent and it will vary, and therefore our analysis will also vary depending on that. So the given statement is not correct. Okay, question number 18 is that acceleration or deceleration of an individual vehicle is a microscopic parameter of the traffic stream. Okay, accept or reject. Okay, we have one vote for A. Any other answers? Okay, so the right answer is option A, that we accept the statement. Okay, so here we are talking about individual vehicle characteristic, right? So acceleration, deceleration is dependent on the particular vehicle, right? So as we saw, there is a wide range of variation in the vehicle characteristics, right? So acceleration and deceleration is one of the vehicular characteristic, and it is dependent on the vehicle, right? So this therefore this is a microscopic parameter, which means it is not defined for your traffic stream as a whole, right? So whereas when we talk about density or the volume or the flow, so these are applicable for the stream as a whole. We are talking about the density of the traffic stream as a whole or the flow as a whole, right? It's not defined for a particular vehicle. Whereas this acceleration, deceleration characteristics, these are on an individual vehicle basis. Therefore, this is a microscopic parameter, right? So the given statement is correct. Therefore, we accept it. Okay, question number 19 is only four conflict points can occur on crossroads with one-way regulations on both roads. Okay, there is one vote for option B. Any other answers? Okay. So the right answer is option B. We reject the given statement. Why? Because so when you have one-way regulations on a four-leg intersection, so you will have not four but six conflict points, right? So we'll have six. Therefore, we reject the given statement, right? So four is not the right answer. So we have one-way regulation on both sides, right? So north, south, and east, west both have one way. In that case, we'll have six conflict points. Okay, question number 20 is which of the given statements are true? So in urban areas, the morning and evening rush hours lead to an increase in congestion. Option B is rural areas may be susceptible to congestion due to recreational and seasonal activities, special events, festivals, etc. And limited options for travel in rural areas may lead to an increase in delays. So we have one vote for both options A and B. The answers. Okay. So the right answer is all the three options A, B, and C are correct. Okay. So in option A, we are talking about urban areas. And what are we saying? We are saying that there is a morning and a evening rush hour where there is an increase in the congestion, right? So this is correct. So when you typically look at the travel time profile, in an urban area, so you'll typically see this kind of a profile. Okay. So your x-axis is the time and y-axis is the travel time, right? So what you'll see, this is this peak that you see in the travel time. So this occurs twice at two different points in time. So one in the morning and another in the evening, right? So the morning, the time whatever is happening, so that is called the morning peak or the morning rush hour. The same spike in the travel time will also be observed in the evening, so that is called the evening peak or the evening rush hour, right? In all the other times, that is called the off peak hours, right? So this is typically observed when people are going to work in the morning time, and the evening peak corresponds to when the people are returning back from work to home, right? So at these times congestions will be higher, and because of that your travel times will also increase, right? So this is the typical profile that you will see in an urban area, and that therefore the given statement is correct, right? So we see two increase in congestions, one in the morning and one in the evening. And then option B is for rural areas. We say that they may be susceptible to congestion due to recreational and seasonal activities, special events, and festivals. Right? As I said, in urban areas, the peaking that we see is mainly due to work trips or educational trips. Right? So people are dropping their kids at school and so on. whereas that is not much prevalent in the rural areas, right? So you will not have that much, work trips or school trips that are happening, right? But the congestion will be created in those areas as well, but because of different reasons, and these are the reasons that we have, right? So recreational or seasonal activities, right? So these kind of peaking patterns, instead of at a day-to-day level, it will be at a monthly level, right? So in some months there will be higher traffic in that particular location because of because that season in that location some activity may be going on, whereas in other seasons it may not be happening. So people will travel to that location during that season, therefore the traffic congestion will be higher in that particular time of the year, right? So this will be a typical trend in a rural area, and so therefore B is also correct, right? And C is again with respect to rural areas, the limited options for travel will increase the delays, right? So this is also true. Again, as we know, in rural areas, the number of travel options are limited, right? So when you consider an urban setting, you will have buses, you will have metro systems, you will have your own private vehicles, you will have taxis, autos, and so on, right? So you have too many options that are available to you, which you can make use of, right? So for example, you are waiting for a bus, and if the bus is taking longer but you need to get to a particular place quickly, you may switch to an auto or a taxi, right? So to get there quickly, so your delay may be reduced because you have multiple options that are available to you. Whereas in a rural area, that simply may not be there, right? So if bus is the only way from which you can with which you can reach, and you do not have a private vehicle, you do not have any other option to use, right? So taxis or autos may not be available, or not maybe may not be available at all the time, right? So therefore, you have to wait for the bus, and therefore your delays will be higher, right? So these limited options may lead to an increase in the travel delays, right? So C is also a correct option. Therefore, all the three are correct statements. Okay. So with that, we come to the end of the session one. Okay, this was the last question. So if you have any further questions or doubts that you have from week one, feel free to ask. Or if you have any feedback to give, please feel free to do so. Okay, so do you have any questions or any other doubts from the content of week one or in any of the questions that we looked at today? Okay, so there is nothing, no more doubts or questions. So we can wrap up today's session. Okay, I hope you found this session useful. Right, so we'll have these sessions every week on Saturdays at 4 o'clock. Okay, so we'll be covering that particular week's content. Okay, in a similar fashion. So I hope that you found this useful, and I expect you to join the next week session as well. Okay, thank you very much for attending, and we'll see you again next week.
Thank you, sir.